Here is one of the most unusual and significant airplanes in the world today, the United States Army's XV-5A VTOL research aircraft. It was designed and 2 aircraft were built by Ryan Aeronautical Company under contract to General Electric, developer of its lift fan propulsion system. Though it looks conventional, it is full of surprises. There is little about its sleek appearance to suggest its unique capability to take off vertically, hover, transition to high-speed horizontal flight, and land vertically. In fact, it is this capability, operation in rugged terrain from unprepared areas, for which it is specifically designed. The most remarkable thing about the XV-5A, without parallel among VTOL aircraft, is that no more basic power is required for vertical flight than for conventional operations. Only the lift fan eliminates the penalty of installing, just for VTOL, far more power than is needed for normal jet fuel. How is this possible? The outstanding efficiency of the Ryan vertifan stems from a new thrust conversion system. When jet engine exhaust is diverted from the normal tailpipe to thin rotor-like fans within the wing and nose, the resulting thrust is multiplied threefold. Relatively small quantities of high-energy exhaust gases are used to drive the fans, which in turn pump large quantities of low-energy, large mass flow air through the fan system. The fans are like multi-bladed airplane propellers, in this case accelerating the air directly downwards to lift the plane vertically. In this concept, the same basic power output serves the entire range of flight modes, hovering to maximum speed. Power and fuel required are the same for vertical flight and hover as for conventional high-speed cruise. The stability of the XV-5A, even close to the ground, during vertical takeoff and hovering has been outstanding, and no tethered tests were necessary before the first liftoff. Maneuverability with precise control has been remarkable. The XV-5A is under positive control by the pilot throughout all flight regimes and stable about all axes. Louvers beneath the fans are vectored to provide directional and roll control. The airplane can easily be translated backward as well as forward and sideways. Control harmony is excellent. Because of the relatively slow, cool downwash of the vertical lifting fans, operation from unprepared surfaces is practical. Until they have flown the XV-5A, pilots find it difficult to believe that it is so easy to fly an airplane which combines the advantages of a helicopter and a conventional jet aircraft. It's far easier than flying a helicopter, is their usual comments. Official United States Army acceptance flights have demonstrated the great potential of the lift fan concept. As a switch is actuated, fan doors are open for the vertical flight mode. During liftoff, the pilot controls rate of ascent by a collective lift stick, similar to a helicopter. Conventional stick and rudder pedals are used for the other controls in both flight modes. For hovering flights, the XV-5A uses the basic thrust of its 2 GE jet engines channeled through a ducting system to the plane's wing fans and a nose fan. The latter controls the airplane in pitch. The plane lifts off effortlessly with no forward speed and can fly straight up as high as necessary to clear surrounding obstacles. The atmospheric air drawn through and accelerated by the fans has many times the lifting power of the jet thrust alone. No other VTOL concept offers this degree of thrust augmentation. The fans provide forward velocity when the louvers beneath them are deflected. The vertifan has the vertical flight capabilities of the helicopters combined with the high performance of a fixed-wing jet aircraft, doing both jobs efficiently without compromise. The landing gear is retracted, and when the 90-knot speed needed for aerodynamic wing-supported flight is reached, a diverter valve shifts the engine thrust from driving the fans to the tailpipe. Conversion from fan mode to conventional jet takes less than a tenth of a second. In this configuration, the louvers and the butterfly doors above the fans are closed. This research aircraft has flown at over 400 knots, but the basic vertifan design lends itself to a speed spectrum of 0 to supersonic. Ryan design studies show many configurations, with various engine and fan arrangements, to accomplish a variety of military missions at supersonic speeds. Engines can be matched to the aircraft mission conditions rather than for the high thrust usually required for vertical flight operations. The vertifan principle, with its 300% augmentation of basic thrust, provides real operational efficiency in a high-performance VTOL aircraft. It means greater payload, longer range, reduced logistic support, and lower fuel requirements. The pilot makes a smooth reconversion from wing-supported to fan-supported flights without change of altitude. The pneumatic exhaust gas coupling between horizontal flight jet engines and the vertical flight lift fans in the wings eliminates the complexity of mechanical power transmissions. The gear comes down and locks, preparatory to the vertical landing. Lift fan aircraft draw on the best features of jet engines for cruise, and fans or rotors for vertical takeoff and hovering. Other VTOLs must carry multiple special lift engines, or engines far larger, more fuel-hungry than necessary for normal cruising flights. Obviously, the plane which can do the VTO job with the least power offers the greatest advantage. Setting the pace for world progress in VTOLs, the potential of the Ryan vertifan concept, as seen in the remarkable performance of the XV-5A, appears as limitless as aviation's own future.